The initial software-driven phase of the artificial intelligence boom is ending. Investors are moving past early experimental applications and focusing heavily on the physical infrastructure required to run them. Recent analysis from Goldman Sachs describes this market pivot as a flight to quality. Capital is migrating away from firms offering narrow AI tools and toward the heavy industrial realities of data centers. Attention is now strictly on the companies that own and operate massive computing facilities. These enormous physical spaces house the servers and networking systems necessary to keep artificial intelligence models online and functioning. The next stage of the AI market will not be dictated by who writes the most elegant code. It will be determined by who commands the physical constraints of the real world. Traditional cloud workloads process sequentially, but training large AI models require thousands of chips running simultaneously in parallel. Because of this, Goldman Sachs estimates AI workloads will consume roughly 30% of global data center capacity within 2 years. To meet this hardware requirement, hyperscale cloud providers, the large companies operating vast networks of data centers, must spend tens of billions of dollars every single year on new facilities and networking systems. Raw computing capacity has transitioned from an abundant digital resource into a scarce physical commodity. This scarcity is actively driving the formation of infrastructure monopolies. Beyond silicon chips, a much harder limit is emerging: electricity. The availability of baseload power is the true bottleneck for AI expansion. Goldman Sachs estimates global data center power demand will surge by 175% by 2030, driven by AI workloads. That increase equals connecting the entire electricity demand of another top 10 power-consuming country directly into the global grid. This severe energy ceiling forces technology firms to restructure operations. Instead of prioritizing software development, companies must focus on acquiring land in remote areas, securing long-term energy agreements, and obtaining water rights for server cooling. The rapid speed of AI innovation is now strictly tethered to the slow, physical realities of civil engineering, utility grids, and heavy industry. During previous cycles of computing growth, a clear pattern emerged. The companies constructing the underlying infrastructure captured stable revenue, while the software platforms built on top of them rose and fell rapidly. Today, data center operators and chip manufacturers sit at the absolute base of the computing ecosystem. Their hardware and services are required regardless of which specific AI applications eventually win the market. Moving forward, the AI economy will rely just as heavily on power plants and cooling systems as it does on algorithms. Investment strategies must account for this physical reality.